Thank you very much. This will be a small departure from what we had previously, just to give a theoretical background on household air pollution. So we'll be discussing about some concepts, how health damaging pollutants are developed, fuel type, the state of cooking in Ghana, and some of the known adverse effects of household air pollution. Then we'll cite some evidence from some of the studies we've undertaken, look at the WHO guidelines, and other social issues related to household air pollution. Household air pollution, we know, is a generation by use of unclean fuel. So when we talk about household, there are two things here. The first thing is the type of cooking device we're using, cooking technology, the type of fuel. So if these two things generate pollution in the indoor environment, then we talk about household air pollution. We know it contributes a lot to ambient air pollution. Once household air pollutant is developed indoor, it never stays there. They come outside to pollute the environment. So we know that household air pollution is a major contributor to ambient air pollution, because everything that is developed indoor eventually comes out. Globally, we know that about 20% of ambient pollutants, especially PM2.5, is from indoor, is generated indoor. We know in Eastern Asia, the figure is a bit higher. South Asia, the figure is a bit higher. But generally, we know that household air pollution contributes a lot to ambient air pollution, especially with respect to PM2.5. And we also know that black carbon, which is the largest contributor to climate change, is from indoor. So we know that whatever we do all the cooking we do indoor contribute a lot to the ambient events that we experience today. One, it contributes to ambient PM2.5. Second, it contributes a lot to climate change. And India, we know household air pollution is the major contributor to ambient PM2.5, followed by power plants. But in effect, even in India, there's a lot of evidence suggesting that ambient PM2.5 is contributed mainly by indoor cooking. We have the same story in Ghana. This is from the LEAP IBC, which has suggested some evidence that ambient PM2.5 is the contribution of household air pollution is quite huge to ambient PM2.5. About 64% of ambient PM2.5 emissions are from indoor. And Accra is about 36%. Greater Accra and Avrongo is also very high. This all suggests that household air pollution is a major contributor to indoor ambient air pollution. When we talk about household air pollution, where does that story start? We know about fuel, right? There are basically two types of fuel: the solid fuel and the non-solid fuel. Within the solid fuel, we have the biomass. So when you say biomass refers to wood, animal dung, crop waste, and charcoal. Now, solid fuel refers to biomass plus coal. Right? So that's a distinction. When you talk about, there's a distinction between solid fuel and biomass fuel. But because globally, biomass fuel seems to be very popular. The term are used interchangeably. Because we know that coal is very popular in South Africa and also in China. But because most countries rely a lot on biomass fuel, sometimes biomass fuel and solid fuel are used interchangeably. So when you talk about the major issue, when you talk about PM2.5, the major fuel that contributes is either the solid fuel or the biomass fuel. How do we generate these pollutants? For example, let's assume that our basic chemistry tells us that if you burn wood, because wood is made up of carbon and hydrogen. You expect to get carbon dioxide and water, theoretically. So what happens? Assuming you burn about 1 kilogram of wood, you expect to generate about 15.3 megajoule of energy. That's the total energy that is expected. However, if those are in a traditional stove system, so for example, if you burned 1 kilogram of wood, we know that only about 18% of that energy goes into heating the pot. 11.3% is wasted as heat, and then 8% is used in generating the bad chemicals. And that's the more reason why in the enclosed kitchens, you see that the kitchens seem to be very hot, because most of the energy that is required to heat the pot is wasted as energy. And so we can describe a typical kitchen as a toxic factory. Why? Because it's a factory that generates a lot of bad chemicals and also a lot of heat. So in a typical kitchen, only 18% of the energy required to be generated is actually used in doing the cooking. So we can sometimes refer to the kitchen as a toxic waste factory. The major issue in the kitchen is incomplete combustion. You remember, when initially I said that if combustion is complete, then you expect to generate carbon dioxide and water and nothing else. But because combustion is not complete, you end up generating a lot of chemicals. From the studies done by NEHA, we know that over 2,000 chemicals are generated in the kitchen. And this is based on some laboratory work that they did in the US. But so far as this household pollution is concerned, what is of interest are the small particles, carbon monoxide, and then PM2 and the particulate matter. However, there are other chemicals that are also generated. These are the hydrocarbons, the oxygenated organics, chlorinated organics, and so forth and so forth. So several other chemicals are also generated in the kitchen. Whenever we try to do our cooking in a traditional fuel, in a typical kitchen, what happens? Because of the fact that the combustion is incomplete and most bad chemicals are generated, we see that if you are using about 1 kilogram, you can generate about 150 milligram per meter cube of carbon dioxide, 3.3 milligram per meter cube of particles, 0.8, and so forth. But if you compare these to the guidelines, you'll see that if you compare what the amount of carbon dioxide that is generated, it's about 15 times more than what is supposed to, what the WHO approved. That's the old guideline, right? And we know that apart from carbon monoxide too, there are other chemicals that has been classified as carcinogen. So in the kitchen, when any attempt made at cooking, you generate a lot of carcinogens in the kitchen, such as benzene, 1,3-butadiene, formaldehyde, and so forth and so forth. In most cases in the indoor household pollution studies, the most important indicator that we use are the particles. But we know that in some studies they also use carbon monoxide, especially in areas where carbon monoxide correlates very well with particles. Then sometimes they assume that because they are correlated, sometimes they use carbon monoxide as proxy. But you know, it depends. In some areas where the concentration is very high, they don't correlate. So it might be wrong to use carbon monoxide as a proxy for particles. So for a very long time, particles have been used. One, they are easy to measure. There are instruments to do that. So particles has been used as the most important single indicator of exposure to household air pollution. And so if the particles are generated indoor, what term is appropriate? Is it indoor air pollution or household air pollution? There has been a confusion in the use of terms. Sometimes we use indoor air pollution, sometimes we use household air pollution. But what's the right term? Indoor air pollution means in the indoor environment there are combustible sources and non-combustible sources. For example, non-combustible sources like radon, lead, asbestos, these are from building materials indoor. And we can talk about molds, fungi, and so forth and so forth. So if you use the term indoor pollution, then it means your interest is not only on the combustible sources, your interest is also on the non-combustible sources. And so the term, we hear a lot of, in most of the cases, people are making reference to indoor air pollution using the two terms interchangeably. And so we want to know which is the right term to use. That household air pollution refers to any pollutant generated in and around the house. Because cooking can be done indoor, it can be done outdoor. So the term household air pollution is a bit different from indoor air pollution. Because indoor air pollution, we are talking about two sources, a combustible source, non-combustible source happening indoor. But the term household air pollution refers to any pollutant, household pollutant generated in and around the household, which could be inside the house or outside the house. Now, it's obvious that most of the studies, I'm sure most of you have done studies on household air pollution, that the measurements are not restricted indoors, right? So sometimes we do the measurement outdoors. So when the kitchen is separated from the entire household, we do some of the kitchen. And we also know that cooking is sometimes done outdoors. So I think the right term to use might probably be household air pollution of indoor air pollution. But when you talk about indoor air pollution, probably it's not appropriate in this context. We know that about 3 billion people are exposed to household use polluting fuels, which is a very big issue. And most of them we know are in developing countries. The regional distribution of household polluting fuel use is very high, we know, in sub-Saharan Africa and almost all poor nations. What is the state of cooking in Ghana? Ghana, about 41.3% rely on wood, 31.5% on charcoal, LPG, not much, and other fuel. But if you look at the rural-urban divide, most of the wood fuel are used in the urban area, which of course makes sense because that's where we find most of the fuel. However, charcoal, because they are produced in the rural areas and sent to the urban areas tend to be the high users of charcoal, right? And this is almost true for all developing countries. Most developing countries, urban settings utilize charcoal a lot. Now, the distribution of fuel use in Ghana, if you look at the western down to the upper west region, it's round south that charcoal and wood is the most predominant source used all the time in the country, irrespective of the region that you find out. So very few people use LPG, although some. And these are some of the activities we use wood fuel for. I'm sure almost every person here is quite familiar with this. We are preparing oil palm. And those environments where people can spend about over 8 hours on a daily basis. So you can imagine how much fume, smoke they're exposed to on the average, people spend about 4 hours in the kitchen. But if you go into the commercial activities, people spend a lot of time in those environments. So commercial exposure to smoke is a very big issue in most developing countries.